scientists have developed an all-season smart roof coating that keeps homes warm during the winter and cool during the summer without consuming natural gas or electricity. Research findings reported in the journal Science point to a groundbreaking technology that outperforms commercial cool roof systems in energy savings. The researcher says that their all-season roof coating automatically switches from keeping you cool to warm depending on outdoor air temperature. This is energy-free, emission-free air conditioning and heating all in one device. Today's cool roof systems such as reflective coatings, membranes, shingles or tiles have light-colored or darker cool-colored surfaces that cool homes by reflecting sunlight. These systems also emit some of the absorbed solar heat as thermal infrared radiation. In this natural process known as radiative cooling, thermal infrared light is radiated away from the surface. The problem with many cool roof systems is that they continue to radiate heat in the winter, which drives up heating costs. The researcher says that their new material, called a temperature adaptive radiative coating or TARC, can enable energy savings by automatically turning off the radiative cooling in the winter, overcoming the problem of overcooling. TARC is the first roof coating that automatically switches between cooling in hot weather to warming in cold weather by regulating its rate of radiative cooling. Metals are typically good conductors of electricity and heat. In 2017, the research team discovered that electrons in vanadium dioxide behave like a metal to electricity but an insulator to heat. In other words, they conduct electricity well without conducting much heat. This behavior contrasts with most other metals where electrons conduct heat and electricity proportionally. Vanadium dioxide below about 67 degrees Celsius is also transparent to and hence not absorptive of thermal infrared light. But once vanadium dioxide reaches 67 degrees Celsius, it switches to a metal state, becoming absorptive of thermal infrared light. This ability to switch from one phase to another, in this case from an insulator to a metal, is characteristics of what is known as a phase change material. The researchers' 2017 study revealed that replacing only 1.5% of the vanadium in vanadium dioxide with tungsten, a technique called doping, lowers the material's phase change threshold to 25 degrees Celsius, an ideal temperature for real-world applications. To see how vanadium dioxide would perform in a roof system, the research team engineered a 2 cm by 2 cm TARC thin film device from 3 layers: a reflective bottom layer made from silver, a transparent middle layer composed of barium fluoride, and a top layer containing orderly blocks of vanadium dioxide islands. TARC looks like scotch tape and can be affixed to a solid surface like a rooftop. The current study demonstrates vanadium dioxide's amazing all-weather versatility in a TARC thin film and compares its performance with a commercial dark roof coating and a commercial white roof coating. The researchers plan to develop TARC prototypes on a larger scale to further test its performance as a practical roof coating. TARC may also have potential as a thermally protective coating to prolong battery life in smartphones and laptops and shield satellites and cars from extremely high or low temperatures. It could also be used to make temperature regulating fabric for tents, greenhouse coverings, and even hats and jackets.